we're going to look at special factoring formulas. But there are procedures that we should do. First, factor out the GCF if there is a common factor other than 1. Determine whether both terms are perfect squares. If the binomial is the sum of squares, it cannot be factored. If it's of the form a squared plus b squared, then you know it is not factorable, it is prime. If the binomial is the sum of squares, it cannot be factored. If the binomial is a difference of squares, factor it by using the formula a squared minus b squared is equal to a plus b times a minus b. Keep in mind that some of the resulting factors can be differences of squares as well, which need to be factored further. If both terms are not perfect squares, determine whether both are perfect cubes. If the binomial is a difference of cubes, factor using the formula a cubed minus b cubed is equal to a minus b times the quantity a squared plus ab plus b squared. If the binomial is a sum of cubes, factor using the formula a cubed plus b cubed equals a plus b times the quantity a squared minus ab plus b squared. These formulas should be memorized as they will help you factor faster. So let's get started with the first example. Notice x squared minus 64 is of the form a squared minus b squared. So I can factor this as a minus b and a plus b. What I usually like to do is rewrite it as something squared minus another something squared. What has to go inside to produce the original polynomial x squared minus 64? Well, I needed x here because x squared is just x squared. And we needed 8 here because 8 squared gives me 64. So these two are the same polynomial in a different form. Then I can figure out what's the a and what's the b. So that allows me to use the formula now. The formula says a minus b. X minus 8 is a minus b. And then the formula says a plus b. Well, a is x and b is 8. And so that's the factorization for our polynomial. X minus 8 times the quantity x plus 8. In this problem, again, it's of the form a squared minus b squared, which we can factor as a minus b times a plus b. I like to rewrite it as something squared minus something squared, so we can figure out what the a is and figure out what the b is. In this case, 5 squared gives you 25, but we also need that a, so we'll put the 5a inside, and when you square it, you do get 25a squared. What squared gives you 49? That's got to be a 7. So here is our a in the formula, and here is our b in the formula. So I can write my answer now as 5a minus 7 and 5a plus 7. This is our factored polynomial. Again, this is of the form a squared minus b squared. So the difference of squares again. A minus b times a plus b is our formula. We'll figure out what we need to square to get a 64. That's going to be an 8. 8 squared is 64. What do we need to square to get an x squared? Well, that has to be x. And so this is our a, and this is our b. So very similar to the previous problems, we can write this as 8 minus x, and 8 plus x. This is our factored form. The next polynomial is x squared plus 100. X squared plus 100. And this is of the form a squared plus b squared, which is, if you look at the beginning of this video, is prime. We can't factor anything that's the sum of squares. So this is not factorable. We say it's prime. In this next example, it's a little bit different. This is the sum of cubes. Since this is the sum of cubes, we need a different formula. And this formula is a plus b times the quantity a squared minus ab plus b squared. So this is the formula. This is the formula for the sum of cubes. So please memorize this formula. It's going to help you out in the future. So let's try this out. Again, to start the problem, I want to figure out what cubed plus what cubed will get back the original polynomial. To make a 125, we need a 5. 5 cubed is 125, but we also need an x to make the x cubed. To make the y cubed, that's just y in here. That's great. Now this 5x, that's our a, and this y, that's our b in the formula. So we can start by substituting it in now. It says a plus b, so that would be 5x plus y times, this part is a squared, so we're going to have to take the 5x and then square it. I like to put parentheses around the whole thing, minus, we'll substitute the a here, which is 5x, and then we'll substitute the b, which is y, plus, it says b squared, so we'll put a y, then squared. Let's simplify the terms. 5x quantity squared is 25x squared. 5 squared is 25, and x squared gives us the x squared. Negative 5xy is negative 5x times y plus y squared, that's just y squared. And so this is our factored polynomial. In our last example, this is of the form a cubed minus b cubed, and the formula for that is a minus b times a squared plus ab plus b squared. Again, try to memorize this one if you can. It will help you factor the difference of cubes much faster. For this problem, I want to rewrite it as something cubed minus, this time, since it's the difference of cubes, something cubed. So we have an x here, because x cubed gives us x cubed back. How do we get a 1000? Well, that's 10 cubed, but we also need a y cubed, so we'll add the y here. That means x is the a, and the b is the 10y. So we'll substitute into the formula now. We'll start with a minus b. That's x minus 10y times a squared, which would be x squared, plus a times b now, which is x times 10y, and the last term is plus b squared. So we'll add 10y squared at the end, and we'll close off that parentheses. Let's simplify. This is x minus 10y times x squared is x squared. X times 10y is 10xy, and 10y squared is 100y squared. And that's the factored form of x cubed minus 1000y cubed.